Section 5.2, our last section in Chapter 5, last section of new material for this class, and it's called multiplication and division of integers. So you're going to see the multiplication models, that's where we're going to start, are going to look a lot like the addition and subtraction models. You may not be very comfortable with the description, but I will describe how it is we go about defining and describing and using that model to justify things like why a negative times a negative is a positive. We're going to actually talk about it from that perspective, okay? So the first model that we're going to take a look at for integer multiplication is the chip model. Okay, so the chip model, I've got -4 times -3, and we're going to write a little bit of description surrounding this as to what we mean when we're multiplying these and looking at these in terms of these chips. So this -4 right here is going to be telling us that we are going to remove, like takeaway, 4 groups of whatever comes next. Okay? So this -4 means we're removing 4 groups of things. 4 groups of whatever comes next. And the whatever comes next is the -3. So this is 3 negative chips. I need to remove 4 groups of 3 chips, and they're negative chips. So they're the red chips that we had once upon a time. Let me get my red chips going on here too. All right, let's actually draw our circle first, and then I'll get my red chips. I need red chips and yellow chips, actually, and I'll show you why. Okay, so right now there's nothing in my circle, which means the value of my circle or in my circle is actually what? 0. Okay? I want to keep my value of my circle 0. And so what I'm going to do is I'm going to do what we did with the subtraction section last time. I'm going to insert pairs of things to keep everything inside the circle 0 for the moment. Everybody good so far? I want my circle's value to be 0. So I'm going to put in a bunch of pluses, a bunch of minuses, or in this case a bunch of red chips and a bunch of yellow chips. Okay? So I'm going to put in I'm going to put in how many I need. Any idea of how many I'm going to need? Yeah, I need 12. There we go. I want to make my circle bigger. I'm going to need 12, so I'm going to put in 12. Now let's say, for instance, you didn't know how many you would need, because the little child might not think through, I need to put in 12. Okay? They might not think through that. Well, if they put in 20, it's okay, because you can always cancel out 0 pairs, right? Anything that's a red and a yellow in there, when I'm done, I can cancel them out because they add to 0. So it'd be okay if I put in extra. So I'm going to put in 12, though. Of each. Six red, 6 yellow, which means that this circle has a value of 0. And I said 6, I meant 12, sorry. 12 red, 12 yellow, I have a value of 0 in my circle. Okay? Since I have a value of 0 in my circle, I'm starting at the same place I was just a little bit ago when I had nothing in my circle. It just looks different, but it still has the same value. But what I want to do, according to the description here, is that I want to remove 4 groups of 3 negative chips. Which ones are my negative chips? They're my reds. So I'm going to circle 3 red chips, and I'm going to remove 4 groups of them. So if I had too many red chips in my circle, I just wouldn't have them circled and removed. I have just enough, so I'm circling, in this case, every red chip. But they're in sets of 3, groups of 3, and I'm removing 4 groups. Does everybody see that okay? So what was once upon a time 0 now is a circle that has things in it that aren't 0. How much is left in my circle? 12 what? 12 yellows, which are positive ones, right? So I actually have 12 left in my circle. So the net result of this is I have the number 12. Okay? Physically, the kids are putting the 2 in at a time, pairs in a time, and then they're removing the 4 groups of the 3 reds. Integer multiplication chip model. charge fields model looks a lot the same, right? It uses pluses and minuses again. So again, this right here would be removing 4 groups. Of, and then right here it tells me 3 negative signs. So I have my circle. My circle has in it pluses and minuses, and I put them in pairs, all right? So again, I know I need exactly 12 because 4 times 3 is 12. So I'm going to put them in pairs. This is going to be all right, it looks like I'm off because I squished them together on the top, but I didn't. I'm not off. All right, there are 12 pluses and there are 12 minuses, which means the value inside my circle is 0. I have to start with 0 when I'm doing multiplication. And then I'm going to do what the problem says. That is, I'm going to remove 4 groups of 3 negatives. And that gives me a circle with what in it when I'm done? 12 positives. For a value of positive 12 as my answer. What would happen if you reversed the description and you said instead of removing 4 groups of 3 negatives, you removed 3 groups of 4 negatives? Would that be okay? Yeah, it would be okay. It would be okay because commutativity. And we're going to get to that one in a second, but there is a commutative property of multiplication. So if I was removing 3 groups of 4 negatives or removing 4 groups of 3 negatives, the result's the same. So I don't want you to get tripped up in thinking that the first number means the remove and the second number means the negatives or positives. It can, but you could also reverse the language and the result would be the same. Okay? All right, last model is the number line model. This is my absolute least favorite one of these, absolute least favorite, and I'll show you why. But let's draw the number line picture. And let me describe for you what each of these things mean, these numbers mean. So this one at the beginning means move left, and it's left because it's negative. If it were positive, it would be right. Okay, so move left because of the negative sign. Move left 4 at a time. Okay, so it'd be like making movements of 4. Okay, so on a number line, you're jumping by 4s. If you were moving left 4 at a time and you were talking about, say, running, you would be running 4 miles at a time. So you're running 4 miles at a time. Okay, so whatever it is you're doing it 4 at a time. Okay, the negative 3 at the begin is talking about the number of time, like the length of time. So this is 3, how did I describe it? I did describe it in hours. This is starting and I'm going to put hours, but it can be whatever units of time you want. 3 hours ago. So let me draw the picture and then I'll explain it again one more time with this language. So this is saying, I'm going to start, here's the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I really probably shouldn't even mark the 0. Just, let me just mark a bunch of hash marks. So wherever I'm starting, I'm going to say I'm starting here, okay? And I'm moving backwards 4 at a time, right? Moving left 4 at a time. So 1, 2, 3, 4 puts me here, and then puts me here, and then puts me here. Okay, so I'm moving 4 left, moving, 4 left 3 times. 3 times I'm moving 4 left. And the answer to the question is not where I end. Where I end is where I am now. The question was, where did I start? Here's where I started. So if my ending point is what I'm calling 0 location, where would I have had to start for that to happen? 12. I don't like this method. I feel like it's awkward. There are some good examples that your book uses for this, though. Talking about, for instance, if enrollment trends were that we lost 40 students a year, what was the enrollment number in our school 3 years ago? That would be this model, this kind of a description, right? I mean, it would actually fit pretty well with this kind of description, but this is the model for this. Okay, let's talk about integer multiplication from an algebraic point of view. All right, let a and b be integers. A is negative and b is negative. So if I were to multiply 2 negative numbers together, a times b, this equals the absolute value of a times the absolute value of b, if they're both negative. That's what we just did on this problem. We did the same problem 3 times, right? -4 times -3. What is -4 times -3? Isn't it just the same as 4 times 3? It is. So if I took the absolute value of -4, I got 4. The absolute value of -3, I get 3. The answer to that is 12, just like I would get if I multiplied 4 times 3. Okay? Now, part B on this, or the second bullet on this, is a little bit different. It has 2 caveats. We either have A is positive, a negative, B is positive, or A is positive, B is negative. This is saying the signs are different. That's what this is saying, right? You have one positive, you have one negative, and I don't care what order it is. It doesn't make any difference. One positive, one negative. What happens? Well, if I multiply these 2 numbers together, I will get a negative number, which is the same as taking the negative, the absolute value of A, times the absolute value of B. The answer is negative. So if I had -4 and +3, the answer is going to be negative. Put that down, and then I just multiply 4 times 3. It's 12, and I write down 12. This is what you do when you do these problems all the time. You don't think in your mind, hey, I'm doing absolute values. You don't think of it that way, but that is what you're doing. You're ignoring the negative, and you're multiplying the numbers, and then you're putting the sign on that's appropriate for that particular problem. All right. Yep, this is a great place to stop. All right, so next time we will continue with properties.